Welcome to clickmyproject.com.
A simulation research on three-phase voltage source rectifier based on double closed-loop feed-forward decoupling control. The system model of the three-phase voltage source rectifier under three-phase static coordinate system is designed. From it, the mathematical model under the rotatory coordinate system is derived. Then the feed-forward decoupling control method is introduced to control the three-phase voltage source rectifier. The simulation research shows that the PWM rectifier under the feed-forward decoupling control method has fast dynamic response and good performance in disturbance injection of load. The feed-forward decoupling control method is introduced to control the three-phase voltage source rectifier. The PWM rectifier based on the double feed-forward decoupling control has a good dynamic and steady-state performance. It has fast dynamic response, low harmonic contents, and a satisfactory anti-disturbance performance under the condition increasing and reducing load suddenly. So the corresponding decoupling is performed to enhance the unit power factor. This is the flow of our project. It consists of 5 modules: voltage source rectifier design, controller design, parameter settings, control the voltage and current components, and performance simulation. In voltage source rectifier design, the three-phase voltage source rectifier is developed with the following parameters. UA, UB and UC are the line voltages. IA, IB and IC are the three-phase currents of voltage source rectifier. LA, LB, LC are the connection inductions between power grid and AC link of voltage source rectifier. IDC and UDC and IL are respectively DC link current, voltage and load current of VSR. Assume power line voltage three-phase symmetrical according to the Kirchhoff law can get the switching function model of the voltage source rectifier under three-phase static coordinate system. Next one is controller design. To stabilize the DC link voltage, can use the output value of voltage regulator as the given value of active component. When the PI regulator is used at a voltage regulator, now the double closed loop feed forward decoupling control strategy could be formed. Output voltage space vector DV and DQV use space vector pulse with modulation technology to generate the PWM drive signals, achieving better control effect. Voltage regulator is used to realize the output voltage stability control. Current regulators are used to make the system active and reactive currents real-timely, tracking the instruction current values. The third one is parameter setting. The simulation parameters are set as follows. Phase peak voltage is 311 voltage. DC link capacitor is 2200 E4-6 farad. Switching frequency is 10 kHz. Line side induction is 10 mH. DC link voltage capacitor is 650 volt. Current regulator KIL is equal to 0.6. KP equal to 25. Voltage regulator K equal to 13. KP equal to 0.5. Simulation time is set to 0 seconds to 0.7 seconds. The resistive load is increased 2 times of the original value in 0.2 seconds and restored in the original at 0.45 seconds. The next block is control the voltage and current components. The constant amplitude sine waveform is the line side voltage of voltage source rectifier. The waveform whose amplitude enlarged 2 times in 0.2 seconds is the current. The input currents of the voltage source rectifier based on double closed loop feed forward decoupling control can quickly follow the grid voltage and near to sine waveform, having fast dynamic response of and low harmonic contents under the condition increasing and reducing the load suddenly. The upper part is a reactive current, the lower part is a active current. In the mutation process of active load, the reactive current is almost unchanged, while the active current waveform can quickly track the changing load. From the waveform, it can also be found that active and reactive current almost realizes the decoupling control. The next block is performance evaluation. A three-phase voltage source rectifier based on double closed loop feed forward decoupling control is studied and a simulation experiment is established and carried out to verify the algorithm under the MATLAB simulating environment in this paper. The simulation results show that the PWM rectifier based on the double closed loop feed forward decoupling control has good dynamic and steady state performance, having fast dynamic response, low harmonic contents and satisfactory anti-disturbance performance under the conditions increasing and decreasing the load suddenly. The work provides important reference values for the system design and hardware experiments of PWM rectifiers. open the source code folder and then run main.mdl file. The Simulink model is developed by using the 3-phase voltage source. For the rectification, we have used 6 switches. Each of the switches is gate pulsar by using the decoupled forward decoupling control. After the load, a sudden increase and decrease in the load changes that restored in 0.45 seconds as shown in as present in the base paper. From this I conclude that our proposed method for decoupling control performs better than the existing method in the literature. Thank you.